Now let us write a function for finding the sum of all these elements. I want to add all these elements one by one. 8 plus 3 plus 7 plus 12 and so on. So I don't have to explain much because already we have learned in the previous videos. Just we have to see the function. So let us write a function for adding all these values. So for adding, I should traverse all these nodes. So we know very well that we need a pointer for traversing all the nodes. That pointer should start from first node. So I will call the function name as add, and it takes a pointer to node type struct node star p. So this p must be first node. Let the return type be integer. So it means I am going to call this function by passing add first. So it will be taking a pointer to first node. P is a pointer to first node. Now what I should do here? I should traverse through all the nodes and go on adding the values. So for adding the values, I should have one variable. Let us call it as sum, and sum is 0. How to traverse all these? So using a loop, we have been doing this while p. So I can write like this. This means p not equal to null. And every time what I should do, sum assign sum plus p caps data or p's data. So I should add. First time 8 will be added to this one, and next time 3 will be added. So like that, I want all of them to be added. So for that, I should move p to the next node. P assign p is next. So if you remember, in the previous examples also we have seen that while loop and this is statement p assign p is next. This will be making p move on all the nodes one by one. So it will help us to traverse the linked list. So what I am doing while traversing, just go on adding the data in sum. So I'll get the sum of all the elements in this variable sum. So finally return sum. The analysis of this function is same. It is order of n because it's visiting all the nodes just once. Now let me write down the same function for finding the sum of all the elements using recursion. I will call the function name as add, same function I am taking, and it's taking a parameter struct node pointer p. Then it should return integer result because all these elements are integer in our example. Now in the recursive method, already we have seen in counting in the previous video, similar approach we have to take. So here I will write down the termination condition. If p is equal to 0, that is null, then return 0. So if it is null means we don't have to add anything. If p is null means nothing is there, there is no element. So 0. Otherwise, else, return, add function will call itself upon next node. So this is next node plus the data of the current node. So plus p's data, p's data. So this is a recursive function. It is similar to count function only, except instead of adding 1, here I am adding p's data. So data of every node will be added. In the count function, it was adding 1 every time, but here it is adding data. So the working will be same, and already we are familiar with recursion. It uses stack. So it's going through all the nodes, so time is order of n, and the stack space is also order of n. So the time and space of this function is order of n.